Hello everyone and welcome back. So in this video we're going to look at exercise 3 of how to find the traces of a plane that contains a lamina. So in this video we have the elevation and the plan view of a square lamina, so basically a lamina with four sides to it. You can see in plan view it looks like a square, and in elevation when it's projected onto the actual plane here you have this kind of diamond-like shape. Now this exercise was chosen because it just brings up a couple of scenarios that you're likely to face in the likes of a Leaving Cert exam, which can throw some people, let's call them kind of exceptions to, I suppose, to the rule. So we're going to use method one for solving this one, which is extending on our line or our edge. Now we could just look at the 3D here and say that, okay, here's our 1, 2, 3, 4 sides. You have to be careful about which edge you extend on. So for this question here, I'm just going to extend on my edges here and here. So that's this edge here and here. I'm going to continue them on until it meets the horizontal plane. So that'll give me my horizontal trace, which is our standard method one. But there's a reason I picked this line and this line here, because these two other lines here are vertical. They're both vertical in elevation and in plan. So when I extend it to the ground, i.e. my XY line in elevation, that's grand. That will give me my point on the horizontal trace in elevation. But when we try to project it into our plan view, because the line is vertical, we don't have a line to cross with it. So we wouldn't actually know where it stops in our plan view. So that's why we can't extend this line and this line here on, because they're vertical in elevation plan. That's what's, I suppose, a typical kind of issue. So you have to be careful about which lines you select. So going with these two lines here, you can see we just extend on our line until it hits the horizontal plane. That's our XY line in elevation. So there it is there. We extend it down and we just extend on our line until it meets the point that we have there. That's our first point on the horizontal trace. And then we do the exact same with our second edge. So there we go, onto the ground, project it down and extend it on, giving us our completed horizontal trace. So there's no major issue there, only that you need to be careful about which edge you select. Now, when it comes to finding our vertical trace, again, we have a similar issue. You can see here, in this case here, we have our line here, which is vertical in plan and vertical in elevation. Here is our line in 3D. If we extended him on, he will of course give us a point on the vertical trace where it meets our back wall or our vertical plane. But to find that using our orthographic, no problem in plan view. There it is there on the XY line. But when we want to find it in elevation, we've no line to cross, so we don't know where it's going to actually end up. So that means that we can't find the vertical trace using extension for this line here or this line here. But we also have a second issue. When it comes to this edge here and this edge here, well, if we were to extend them on, well, they will never actually meet the XY line here because they're parallel to it. So extending that on, it won't actually ever come into contact with the back wall, so it'll never actually meet the vertical trace. But if you look closely at the 3D here, you can notice something, that the edge that we have here and here, they're actually parallel to the vertical trace. So even though, I mean, if you're stuck into the idea of extending it on, you're going to run into a problem. But the actual problem is solved much, much simpler, as far as that line there, well, he's parallel with the horizontal or the vertical trace in plan view, because the vertical trace is seen on the XY line. So it should also be parallel in elevation. So all you need to simply do is see they're parallel, so they will be parallel in elevation. So if this is the line in plan, this is the angle of the line in elevation, you just simply set your compass to that line there and then just draw it from where our point T is here. So you can see there's our traces parallel in our plan view. There's our line parallel to the vertical trace there in elevation. And that's the actual solution completed there. So it's an unusual question. It throws up maybe a couple of issues, even though it's very, very simple to solve. Because it's an exception of that, it does tend to throw students. And a lot of the time you'll see that appearing in the Leaving Cert, because it really requires a student to have that kind of maybe a little bit of a deeper awareness. Okay, if you're just stuck into the habit of extending the line onto the actual XY line in plan view, well, all of a sudden you've got this issue that it can't be done, and people get stuck rather than saying, oh, if it doesn't meet it, well, it must be parallel to it, and just drawing your parallel line. So it's just a very, very sneaky thing in some ways, but a simple solution to it. So that's method one then for finding the vertical and horizontal traces for our lamina.